I realized there was a couple problems, or at least missing parts from my lerp function. One is that you could write a value of t less than 0 or greater than 1, and it would effectively cast it way out potentially into infinity. So what can we do about that? Well, in here we could say t is actually equal to, or let's say, yeah, let's do t is equal to, because we're not passing that variable back, min of either t or 1. And so it won't ever go above a value of 1. And then instead of t in here, we can actually throw in the max, and we can say take the max of t or 0. And so inside the max function, never go below 0. Inside the min function, never go above 1. And so now we've capped our t value so that it's between 0 and 1. What's the other potential problem? Let's see. Well, we capped it at both ends. I think that solves everything. I thought there was another problem. So if we have a negative t value, it'll come in and it'll be at the start position. If we have a t value that's way off in infinity, we would be capped at 1. I don't know why I convinced myself there were two problems. Maybe I was thinking the min and the max. We got to cap it at both 0 and 1. So we've done that now. And if we wanted to, let's go back. Already written some of the other code. Let's test that out, right? Let's, instead of this, if you haven't already watched this video, I'll put it in the right spot. We had it so that it would lerp from one spot to the next. So what if I intentionally threw some problems at it? Let's say just use straight talk value instead of talk divided by time to lerp. Well, that would mean that we're moving 1 second movements every single time. So, and then it would move in 1 second and then just like stay there, right? If we've set up our min and max function correctly. So it stays there, picks it up, stays there, moves, stays there. There's a bunch of pauses in between the moves, and those are that additional time that it's not. Still moves really fast back. All right, so that kind of fixed the lerp function. I might come back because I'm convinced there's another problem with it. Technically, I guess the only other issue is the talk never truly equals time to lerp, right? Let's fix that. So at the end of this, we've got a lerped position or interpolated position that we move to. But when the time has elapsed beyond what we set it up to be, it's possible that we're like at 99% or 98% of the total movement required. So we could address that by saying, well, it's less than time to lerp plus 1%, or after we do this, we could actually move it to the next position. And so we could say, after this, we want to write position P. And so that guarantees that it'll actually move to that final position. It's not going to pick anything up because that block is, oh, never mind, I was wrong. and or operators. 34. Right position, P. Where do I have an or and operator? I'm very confused. So we're trying to write specific. Oh, there's no p-value. Oh, we're using a value that's not. We actually want to write. P comma I. So position set of positions and then increment through that row. So we don't see anything different, and that's because it was getting to like 98 or 99% of the total distance moved to that final position, and then it would start lerping to the next one, right? And so it would jump to that other trajectory and start moving along that one. So we don't see a difference because there wasn't a huge difference in the first place. But also it was mildly self-correcting. We didn't actually need it to move to the exact position at the end of the lerp, but this would get you to that final position. Alternatively, if you sent any value 1 or greater, it would actually get you there too. There are alternative functions or versions of the lerp routine. One takes into account that you can have floating precision errors, which is effectively we don't really worry about it much in MATLAB because most of the time it's such a small amount. But if we wanted to address that, we can actually change this equation a little bit. We could say instead we'd take 1 minus t times start position plus t times end position. And the way that it's set up would essentially just like gives us a little bit better precision in terms of getting to that final value instead of the first version, which, to be honest, is the one that I remember first anyway. But that if you were worried about 10 to the negative 15th difference between those two values, that second version would get you that little bit better. But the robot arm isn't that precise. One more time.